Hello, friends. So today we're going to create a nth root calculator with Python that will calculate any number that the user can input its nth root. So to do this, this is a plan or a pseudocode of how the program, what the program should do and how it should flow. So we have 5 functions. The first one is nth root of all positive numbers. Then we'll create one for nth root of odd negative numbers. Then nth root of even negative numbers. And then we have 2 additional functions for printing and output. So I've said optional, but I will actually make those. So it'll print out nicely what the root is of the number that the user inputs. And then we're also need to get the user input for both the number and its nth root as in the main function. And nth root must or should be an integer. It must be an integer, actually. All right, so in the main program or main function, we need to consider the case when x is 0 and print its nth root to the user, and then call each of the functions in main. And we also need to be mindful of how the program should flow and command of the program. And then lastly, handle exceptions and ability to keep running the code. So that way the user can quickly input many numbers without needing to hit play in the VS Code. Or if you don't have VS Code, then if you have only Python, if you've only installed Python, then this would really be helpful to you if we can somehow just keep running the code once we create it. All right, so let's go ahead and jump to VS Code. I've already created a new file called nth root and made a comment that this is a nth root calculator. So let's go ahead and make the 5 functions that we said we need to make, and after I make them, I will go in more detail in what they're doing. So I will go ahead and start making those functions now. All right, so I've made the 5 functions. The first function is the positive nth roots function that will take x and n as parameters, and the root is x to 1 over n. So this function will take care of basically half of the numbers in the real numbers. So that'll be the positive numbers from anywhere from numbers bigger than 0 to infinity. And then it'll call the print n function that I've created down here. So this function is basically for formatting purposes. When the user inputs, say 64 or 9 or something, it'll say the nth root, or the n would be a number. So we say the second root of 64 is 8, or maybe the sixth root of 64 if the user inputs n as 6, sixth root of 64 is 2, and so on. All right, and then the second function is odd negative nth root function. So for this function, I had to import CMath, and then I have created a few variables in this function because I couldn't combine exponent, logs, and polar into one line of code. So the first line is cmath.exponent cmath.log x to 1 over n. So that's how I would take care of negative roots in terms of exponents and logs. And then the second line of code, root 2, is cmat.polar. So what that does, it converts it to a polar form. This is in rectangular form. We want it nicely printed out. And then root 1, it'll take the first number of those roots. So because in Python, the roots are really long, and we want only the first one that will give us the actual root of the number. And then we multiply that by -1 to get the root that we want. And then we call the printn function that we did in the first function to print the results, because say if the input is -8, we want the third root of that to be -2, and this function will take care of that for us, the printn function. And then lastly, the even negative nth root function is very similar to the odd root function, except that in the printing and formatting, I've created another printing function that is specifically for this nth root when the even negative nth root function is inputted, because we want j. Say for example, if the user inputs -9, we want the program to spit out negative or 3j, something like that. And this function will take care of that. So that's all the functions we need. Now we can jump into creating our main function. So let's do that. So here I'm going to create a Boolean variable flag, set it equal to true, and then while flag, while flag. So what we want to do is we're going to get the user inputs for x and n, and then print out the results. So I'm going to actually do the try except block also. Try x equals inputs, and then let's do enter a number. And then n equals integer. We said we want n to be an integer. Let's see, enter the nth root. So this is in the form of 1 over n. All right. So while not n dot is integer, I'm actually not sure if this line of code really, this part of the code works or not, but let's put it in anyway. Or n is less than 0. And then so this part of the code with this while loop, it takes care of user inputting negative numbers for n. So we don't want to compute the nth root when n is less than 0. We also don't want to compute when n is say a string or something like that. But I'm not sure if this function is working. I've tried it before and it didn't do anything, but we'll put it in there anyway. And then let's do accept, just accept, so print invalid inputs. Okay, and then print a blank line. All right. And then else. So in our else block, we're gonna actually compute all the other possibilities. So when the user inputs numbers, we want to call our functions and do the computations. So else if n is 0, so we want to include that case we said in our pseudocode. So if n is 0, so we're gonna do just print a nicely formatted string. Okay. So, oops, this needs to be indented. So if n is 0, like this. So if n is 0, we want to say to the user 0 to the power of that number is another number, and that would be x would be 0, n would be the nth root of 0, and 1. Actually, yeah, if n is 0, then any number to the 0 power is 1. So this is where this one is coming from. And then we set flag to false, so we can get out of this line of, so our program can just shut down from there. We can exit out of this block, else block. All right, so what if n is not 0? So if x, or actually, yeah, if x is less than 0 and n in range 2. So if x is less than 0 and n is in this range, so I've created you can create your own range, but basically we want a range though that would take care of the odd numbers from 1 to this 25 I've created. You can do it 1 to 9, 1 to 13, whatever you like. And this 2 is the step size, so this step would be in increments of 2, so it'd be 1, 3, 5, 7, and so on. So if this is true, we're going to call this function odd nth, negative nth roots. So just copy and paste that here, and then flag equals false. Oops, flag equals false. All right. So if x is less than 0 and n range, this will be the even numbers now for the when n is less than 0, or x is less than 0. Sorry. So I've created 26. Again, you can change this if you'd like, but this way we start from 2 and we go from increments of 2 up to that number. In this case, 26. So in this case, we're going to call the even nth roots, negative nth roots, and then flag equals false. So we can execute it, and the program, can get out of this else block. So else, if n is not 0, not equal to 0. So now we're going to call the function that will take care of half of the numbers. So we'll call the positive root function, and then flag is false. Okay, let me just double check. Looks like I have all of my code. All I need to do is include a way for the user to keep running, to have the ability to keep running the code. And to do that, I will go to the first to this line here under main. So let's say while true, and then we have to indent everything here. So this is print. This is a blank line of code. Oops. All right, so blank line of code, and then we ask the user if they want to exit the program or not. So we'll call y for yes. Y. So if answer equals y, we want to break. All right, so let's go ahead and start the program. So we'll call the main function and see if the program is running. So I need to double check. All right, so I've created our program. So let's go ahead and test some numbers that I wanted to test to see how our program is running. Let's go ahead and hit play. So we can enter 9, and then nth root, let's go ahead and do 2. The second root of 9 is 3. So I don't want to exit, so hit another key. Second number, -8, 3. It says the third root of -8 is -2. So let's test -16, 4. And then the fourth root of -16 is 2j. Let's test 0, and then 8. The eighth root of 0 is 0, and let's do 1, 5. So the fifth root of 1 is 1. And lastly, let's check some things that are not numbers for like strings and so on. So let's go ahead and type R. It says invalid, so it takes us back to entering a number. Let's put in a number, and nth root, call it John. it takes us back to entering a number, so it doesn't go back to the nth root. But let's say if we wanted to do a number 7 and nth root would be -8, it takes us back to the command of nth root instead of going back all the way to x. So if we enter a number 7, so that's the 7th root of 7 basically. And let me just go ahead and exit out, and that exits out of the program. So that's how we make a nth root calculator using Python. Thanks for watching.